Good evening everyone. Good evening. कैसे हैं आप लोग? How are you? So many students were requesting me, sir, please take the revision class on smart board. So I came here and I'm going to take the class on smart board. So first of all, those who are coming first time to our YouTube channel, let me introduce myself. My name is Devendra Negi and GATE All India Rank 1 2019. 1 minute. Yes. GATE All India Rank 1 2019-2020 in Engineering Sciences paper. I completed my MTech from IIT Bombay. I am teaching for GATE and ESE since 8 years. The subject which I am taking are thermodynamics, applications of thermodynamics, fluid mechanics, Hurd-Leak machines and heat transfer. So those who are coming first time, kindly subscribe this YouTube channel because this is going to be one-stop solution. ये आपका one-stop solution होने वाला है for any competitive exam preparation. For any competitive exam preparation, if you are preparing for GATE, if you are preparing for engineering services, or maybe civil services, you are taking mechanical as your optional, then this channel is going to help you. What is the name of the channel? Unacademy GATE MEPIXE. So shall we move forward? Bolo re baba. Okay, those who are there, kindly hit the like button, mark your attendance लगा दो रे बाबा, तब आगे चलते हैं. Attendance लगा दीजिए, then we will move forward. Okay, so today listen carefully. I will be telling you today what are we going to do. I will be telling you, my friends. So today basically we are going to have the revision of fluid mechanics FM chapter 1. FM chapter 1 we are going to revise. Tomorrow also we will be revising FM chapter 1 only. It will be continued. Then day after tomorrow, that means on 30th of July, I will be taking 3 hours class for the revision. Are you happy? I will be taking 3 hours class for revision and we will be doing the revision of FM chapter 2. We will be doing the revision of FM chapter 2. Chapter 2 we are going to revise. 3 hours. Sir, what will be the timings? 3 p.m. to 6 p.m. 3 p.m. to 6 p.m. we will be revising the chapter number 2 on 30th of July. Then on 31st I will be revising chapter 3 and chapter 4 for you people. Again the same timing, 3 hours continuous class, 3 3 p.m. to 6 p.m. Now one more important thing. So many of you were requesting me, sir, can you give some information about engineering sciences, about XC paper. So my friends, tomorrow at 4:30 p.m. I will be taking one session on engineering sciences paper just for you people. I will be taking one session on engineering sciences. What are the papers what are the subjects basically through which you can write the engineering sciences paper? What are the career opportunities through engineering sciences paper? Everything I will be telling you in detail. Are you happy? Bolo re baba. Are you happy till here? यहाँ तक आप clear हैं? चलो. Excellent. Yes. Chalo then. Let us start revision part. I hope everyone is clear. Let us start this revision part. Fine. So today we will have little bit of revision. I will be telling you what are we going to revise. So don't worry, my friends. Chalo. Now we started chapter number 1. We started this chapter number 1 with basic definition of fluid. So anyone in the class, what is fluid? You remember what I told you? Fluid is the substance. Fluid is the matter or substance which can flow. Yes or no? This is what we have discussed. Fluid is the substance which can flow. Then you remember I told clearly, fluid can be categorized into 2 substances. What is that? Liquid and what? Liquid and gas. I hope you are clear till here. So basically the substance which can flow is known as fluid, and then the fluid can be categorized into 2 parts, liquid and gas. Now Now this is what I have given you. This is what I have given you. The substance which can flow is known as fluid, liquid, and gas comes under the category of fluid. Now the branch of science which deals with statics in bracket at rest and dynamics of a fluid. Dynamics means what? In motion of a fluid is known as fluid mechanics. This is what we have seen. Now we started chapter number 1. You remember, we started chapter number. Your complete revision will be done here only. You have learnt majorly 4 chapters: fluid and its properties, pressure and its measurement, where I will be discussing the accelerated vessels also, where I will be discussing the vortex motion also. Then we have discussed hydrostatic forces, buoyancy and flotation, and it is very important, my friends. It is very important. I will be discussing the revision of all these chapters. So fluid and its properties. Now here we have discussed about solid. I hope you are able to recollect. अगर आप देखेंगे क्या डिस्कस किया था बेटा? Let us suppose I'm having a fixed plate. And let us suppose I'm having a solid. And let us suppose on the top, let us suppose I am having some movable plate. Now listen carefully. Let me say this plate is moving with the velocity v. Now listen carefully, my friends. Try to understand. What was your observation? Solid undergoes what? I have told you clearly. First point, you remember, solid undergoes what? Finite deformation. This is my first point. Always remember, solid will be undergoing finite deformation. Do you remember that? Second point, what was that? In case of solid, shear stress is directly proportional to what? D theta. Shear stress will be directly proportional to what? Shear strain. And what was the next point? Do you able to recollect? It depends. If I am applying, look at here. If I am applying the shear force 100%, this solid will be undergoing some finite deformation. Now when I am removing this shear force, whether this solid will regain its original position or not, it will be depending whether the deformation is elastic deformation or plastic deformation. So it depends. It can regain or it will not regain the original shape. It depends, beta. It depends. Fine. These are the points related to solid. So what is that? Look at here. If we apply, excellent, I am very happy. Keep writing. Yes. So if we apply some external shear force on solid, it undergoes finite deformation, d theta, or breaks. Second point, for solid, shear stress is directly proportional to d theta, which is known as what? Finite deformation on finite shear strain. Now the next point, if we remove external shear force depending on deformation, elastic or plastic solid may or may not regain the original shape. Is it clear to everyone? यहाँ तक आपको clear हो गया? Are you clear till here? Chalo, next, fluid. Next point, fluid. Anyone in the class, are you able to recollect what is fluid? Look at here, we have discussed na? Let us suppose, देखिए ध्यान से. Yes, let us suppose I'm having a fixed plate. Let us suppose this is some liquid which is kept between fixed plate and movable plate. One minute, yes. This is the movable plate. Moving with the velocity v. Now look at here. This is your liquid. Now what have we seen here? What have we seen here in this case? What have we seen here in this case? Do you remember? Do you remember what we have seen? First thing, first point. What was the first point? What was the first point here? What was the first point here? Yes, yes, excellent. Fluid undergoes what? Fluid undergoes what? Fluid undergoes what? Continuous deformation. Fluid undergoes what? Excellent. Fluid undergoes continuous deformation. There is no doubt. Fluid undergoes continuous deformation. If I am applying some external shear force, fluid will be undergoing continuous deformation, and it is known as flow. It is known as flow. Second point. In case of fluid, what happens? Shear stress is directly proportional to d theta by dt. What is this d theta by dt? What is this d theta by dt? Do you remember? Shear strain rate. In case of solid, tau was directly proportional to d theta. Here it is directly proportional to d theta by dt. And of course, here fluid never regains original shape. Fluid never regains original shape. Everyone knows this. I hope you are clear with this. Now look at here. This is the thing which we have seen. If we apply some external shear force on fluid, it undergoes finite deformation. This continuous deformation is known as flow. For fluid, shear stress is directly proportional to d theta by dt, where d theta by dt is what? Deformation rate or shear strain rate. The next point, if we remove external shear force, fluid never regains its original position. Original shape, except some viscoelastic fluid which partially regains the shape. Biological tissues, polymer solutions, jelly are the example of the viscoelastic fluid. This is what we have seen. Now after this, we have seen what? Beautiful conclusion. What was the beautiful conclusion? Are you able to recollect? Fluid is the substance which cannot resist. External shear force. Fluid is the substance which cannot resist any external shear force. Are you clear till here? Chalo, next. Then I have asked you, can you draw the Mohr circle? For what? Hydrostatic condition. What is the meaning of hydrostatic condition? Beta, what is the meaning of hydrostatic condition? क्या मतलब है hydrostatic condition का? देखिए, what is the meaning of hydrostatic condition? Look at here. Anyone in the class? What is the meaning of beta hydrostatic condition? Let us suppose I am having some liquid. One minute beta. I am having some liquid which is at rest. Static means, let me say, at rest. I am having some liquid which is at rest. Now listen carefully how the Mohr circle will look like for this particular situation. Look at here. Let me say this is one axis. Let me say this is another axis. You know na? This is what your shear stress axis. This is your normal stress axis. What happens in this case? What happens in the case of hydrostatic? Do you remember? My friends? I will be telling you. In this case, what is going to happen? Look at here. Let us suppose I am taking one small fluid particle. Let us suppose I am having some small fluid particle. On this small fluid particle, everywhere, very small fluid particle, we will be having the pressure P all around. And we know pressure force is always external normal compressive force. So because of this compressive force, what will happen? Compressive stresses will be generated within the fluid particle. So what I'm going to have is, I will be having the Mohr circle like a point. It will be a point, and 100% what will happen? This will be equal to what? P. This will be equal to P. I hope everyone is clear with this. Now, we started the chapter number 1, fluid properties. We have discussed about the fluid, then we started fluid properties. What is fluid property, my friends? First thing, density, mass density or density. What is density? What is density, my friends? Density का क्या formula बताया था मैंने आपको? Anyone remembers what is the formula of density? Density in bracket rho is equal to what? Density in bracket rho is equal to what? Mass in bracket m divided by what? Divided by volume in bracket capital V. I hope you are able to recollect this. And then I have told you the units also. Do you remember the units? Of course, density की unit क्या होगी बेटा? kg per meter cube, and of course if you are looking for the dimension, किसी को पता है dimension क्या होने वाली है density की? Of course mass m, volume is what? L cube. So ml minus 3 will be the dimension of density. I hope you are clear till here. यहां तक सब लोग क्लियर हैं? Yes, very good. I want everyone to type. I want today everyone to type. It is your revision. You will be typing in the chat box. Yes. Then you remember I have told you one physical meaning of the density. Physically, density represents what? Heaviness of the fluid. And I hope you are able to recollect. I have given you the densities of various fluids at 20 degrees Celsius. Yes. Then listen carefully. What will be the effect of temperature and pressure on density? Anyone is able to recollect? Look at here. Density is equal to what? Mass divided by volume on increasing temperature. ध्यान से देखना बेटा. On increasing temperature, what will happen? Let us see. On increasing temperature, what will happen? Please observe. On increasing temperature, look at here. Density is equal to mass upon volume. Mass remains same. Mass remains same. What will happen to volume if I am increasing temperature? Volume increases. Then what will happen to the density? Density decreases. This is the case if I am increasing the temperature. Let us discuss the second case. On increasing pressure, what will happen? Let us see. On increasing pressure, what will happen? Let us see. Density is equal to mass upon volume. Mass remains same. If I am increasing the pressure, what will happen to the volume? Volume decreases. Generally volume decreases. So 100% density increases. Yes, very good, my friends. So if I am increasing the temperature, density decreases. If I am increasing the pressure, density increases. Yes. Now next, the density of the common fluids. At 20 degrees Celsius and 1 atmospheric pressure. So you need not to remember so many things, but I hope you are able to recollect. What was the density of water? At 20 degrees Celsius and 1 atmospheric pressure? Approximately 998 kg per meter cube, and this can be written as approximately what? 1000 kg per meter cube. Fine. This was the density of water. What was the density of mercury? Anyone remembers? 13,580 kg per meter cube. This was the density of the mercury, and approximately we are writing 13,600 kg per meter cube. Yes. Actually, this value of density of the water occurs at 4 degrees Celsius, since it is the maximum density of the water. Yes. Excellent. Yes, very good. Excellent. Yes, Mujammil, very good. Nagasai, very good. Sohail, very good, beta. Very good. Mithilesh, Ravi Sau, very good. Or a jam revision you people are doing. I am very happy. Few people are doing the jam revision. Yes. Then I have told you what is specific volume. Bolo re baba, specific volume kya hota hai? Specific volume is equal to what? Volume divided by mass. Volume per unit mass is known as specific volume. And can I say specific volume is nothing? It is what? Reciprocal of density. Specific volume is what? Reciprocal of density. What will be the unit of specific volume? Specific volume unit will be what? Meter cube per kg. Will be the unit of what? Specific volume. Very good. Then we came to the next topic, weight density. What is weight density, my friends? It is also known as what? Specific weight. Weight density is also known as what? Specific weight. What is a specific weight? Weight per unit volume. Weight per unit volume is known as what? Specific weight. It is represented by small w. Small w is what? weight divided by volume, weight divided by volume. So weight divided volume is known as a specific weight, and look at here, weight is what? Weight is what? M into G. So M into G divided by volume, M by volume will be what? Density. So specific weight can be written as what? Rho G also. This is the thing which you have to remember. This is the thing which you have to remember, because number of times they will be giving you the specific weight in the exam and you need density. So if you divide specific weight by G, you will be getting the density of the fluid. So keep in mind, specific weight is equal to density of the fluid into what? Into G, into G. Are you clear till here? Yes, 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 yes. So effect of temperature, pressure and location on specific weight. Effect of temperature, pressure and location on specific weight. So what will be the effect? Look at here, look at here. Specific weight is equal to what? Rho G, rho G, rho G. First point. On increasing temperature, let us suppose if I am increasing temperature, what will happen? On increasing temperature, specific weight is equal to rho into G, G will not change, G remains same, but what will happen to the density if I am increasing the temperature? Density decreases, the moment density decreases, what will happen to the specific weight? Specific weight also decreases, First point. Second point, on increasing pressure, what will happen? On increasing pressure, look at here, on increasing pressure, let us see what will happen. If I am increasing the pressure, what will happen? Let us see. Specific weight is equal to rho into G, Of course G will not change, but if I am increasing the pressure, rho will increase, rho increases, density increases, and if density increases 100%, specific weight also increases, there is no doubt. Now the third point, on changing location. I have told you, if you are changing the location, it is quite possible G will change. For example, G at pole is more than G at equator. So 100% if you go at pole, the specific weight will be more as compared to specific weight at equator. Okay. Yes. Sir, red color mark use. Why? Is it this blue color is not visible? This blue color is visible or not? Bolo re baba. This blue color is visible or not? Yes. Excellent. Very good. Next. Specific gravity. Very good. What is specific gravity? We are representing specific gravity by small s. It is what? Density of the fluid divided by density of standard fluid. What is a standard fluid? As per our definition, now I will not discuss other things. According to our definition, standard fluid is what? Standard fluid is what I have discussed earlier. What is standard fluid? Standard fluid is what? Water at 4 degrees Celsius and 1 atmospheric pressure. The water which I am having at 4 degrees Celsius and 1 atmospheric pressure, that is behaving as what? Standard fluid. Yes. Chalo. Visible. Excellent. Now look at here. Liquids having a specific gravity, ये मैंने आपको बता रखा है. If the liquid is having a specific gravity less than 1, it will be floating over the water. But if the liquid is having density more than specific gravity more than 1, if the liquid is having a specific gravity more than 1, it will sink in water. It will settle at the bottom. Now, you remember I have told you, yes, you are correct. Whatever the standard fluid we are having, that is having the density of 1000 kg per meter cube. That is having the density of what? 1000 kg per meter cube. Now listen carefully. Relative density. What is relative density? Relative density is the ratio of any two random densities, rho 2 by rho 1. Rho 2 by rho 1 is known as what? Rho 1 by rho 2 is known as what? Relative density. When I'm not dividing with this standard fluid, it is not a standard fluid, it is not a standard fluid, it is not a standard fluid, then I can say the ratio of two random densities will be what? Relative density. Are you clear till here? That means, can I give one conclusion over here? Can I give one conclusion over here? What is the conclusion? What is the conclusion? Can I give one beautiful conclusion here? Every specific gravity is relative density, but every relative density is not the specific gravity. अरे क्या हो रहा है यहाँ पर? ध्यान से देखो. Specific gravity is one special case of relative density where the denominator density becomes the density of the standard fluid. So I can easily say every specific gravity is the relative density, but every relative density is not the specific gravity. Next, cohesion and very easy. What is cohesion? क्या होता है बेटा? Cohesion is the force of attraction between same nature molecule. Cohesion is what? Force of attraction between the same nature molecules. Whereas what is adhesion? बोलो रे बाबा, what is adhesion? Adhesion क्या होता है? What is adhesion? Oh ho. बोलो रे बाबा. Yes. If you are having same molecules, if you are having same nature molecules, then 100% you will be having cohesion. And if you are having different nature molecules, then the force of attraction between them will be what? Adhesion. I hope everyone is clear till here. Now, then we have done one beautiful thing. What was the observation? One by one I will be telling you. What was the observation? One by one I will be telling you. The first thing what we have seen is because of cohesion what happens? Look at here, मैंने आपको बताया था. I have told you, because of cohesion only what happens? The small objects can float over water. Yes, we have seen that. Now means what? It can take the tensile load. I can write in this way, better you will be able to understand. I can say in this way, because of cohesion liquid can sustain tensile load. Because of cohesion only liquid can sustain tensile load. Now what is the main aim of adhesion? Yes, adhesion. Because of adhesion only what happens? Liquid sticks to the surface. Yes, we are absolutely clear with this. Now you remember I have told you clearly. याद है आपको मैंने clearly बोला था. क्या बोला था मैंने आप लोगों को? Do you remember? In case of gas, cohesion is negligible. In case of gas, cohesion is negligible. Can you tell me why, beta? Can you tell me why cohesion is negligible? Anyone in the class? Why cohesion is negligible in the case of gas? Because gas molecules will be having the random motion. Here and there, they will be moving randomly, and the cohesion will be negligible. In case of liquid, there will be some cohesion. And if I am increasing the temperature, look at here, on increasing temperature, anyone in the class, what will happen? On increasing temperature, what will happen? Anyone in the class? On increasing temperature, cohesion of what? Cohesion of liquid. What will happen to the cohesion of liquid? Cohesion of liquid decreases. Cohesion of liquid decreases. Why cohesion of liquid decreases? Why cohesion of liquid decreases? Because now the molecules will be having little random motion. Because when I am increasing the temperature, random movement will increase for the liquid molecules and 100% cohesion will decrease. देखो cohesion enables liquid. Yes, cohesion enables a liquid to resist tensile load. Yes, because of cohesion only a liquid can resist tensile load, while adhesion enables it to adhere, stick to the other surface. In case of liquid, cohesion is dominating, but in case of gas, cohesion is negligible. Why negligible? Because of random movement of the gas molecules. On increasing the temperature of liquid, randomness of the liquid molecules increases, leading to decrease in cohesion. Now listen carefully. Here I am having one more beautiful concept. What is the concept? Ideal fluid. What is ideal fluid, Ray Baba? Type in chat box and tell me what is the ideal fluid. What is ideal fluid? Listen carefully. What is ideal fluid? Listen carefully. There are two assumptions which we are having for the ideal fluid. Listen carefully. Ideal fluid is an incompressible fluid having zero cohesion. So there are two things. First thing, ideal fluid is incompressible fluid. Second thing is it will be having the zero cohesion. And the moment I'm saying ideal fluid, don't be confused with ideal gas. Ideal gas is something else which we will be discussing in thermodynamics. Ideal fluid is something different which we are discussing in fluid mechanics. Are you clear till here? Yes, very good. Bolo re baba, are you clear till here? Are you enjoying the revision session? Bolo re baba, are you clear till here? Yes. Type in chat box re baba. Type in chat box. Kar do re baba chat box mein. Yes. Excellent. Yes, very good. Now, I discussed the concept of what? Fluid at rest and relative rest. I have discussed the concept of what? Fluid at rest and relative rest. What is the meaning of this? Look at here, beta. Look at here. Let us suppose this is the car we are having. Oh, what a beautiful car. Let me say on the top of this car, I'm keeping one container. Now look at here. These are the different layers. Of the liquid. Now, if this car is not moving at all, V is 0, then 100%, look at here, the relative motion between two liquid layers will be 0. No relative motion. Look at here, my friends. No relative motion. Yes. And there is one more thing. Let us suppose the same car starts moving with constant acceleration. Let us suppose same car starts moving with constant acceleration in this direction. So what will happen? Kya hoga beta? We will be getting something like this. Now what will happen here also in this case? There is no relative motion. But you know, I have discussed earlier clearly. This is the case of what? At rest. If you see from your reference, this car is not moving at all. So it is the case of fluid at rest. And this is the case of what? Fluid at relative rest. If you see from your reference, your frame of reference, fluid at relative rest. If you see from your frame of reference, 100% this fluid is moving, but there is no relative motion between the fluid layers. So remember, whether I am having fluid at rest or fluid at relative rest, 100%, what is going to happen? The relative motion between two fluid layers will be 0. There will be no relative motion. Between two fluid layers. Yes. Now, no slip condition. What is no slip condition? I will be telling you. What is no slip condition? I will be telling you. Listen carefully, my friends. Listen carefully. Suppose I am having a fixed plate. Let us suppose I am having a fixed plate. Let us suppose I am having a fixed plate. Now let us suppose on the top I am having one movable plate. Let us suppose on the top I am having one movable plate. Movable plate. Movable plate. This is your fixed plate, beta. This is your fixed plate. This is your fixed plate. This is your fixed plate. Now listen carefully. Now listen carefully. Let us suppose between fixed plate and movable plate. Let us suppose in between fixed plate and movable plate, I am keeping some liquid. I am keeping some liquid. Now let me take the values also. Let me say this movable plate is moving with the velocity of 10 meter per second. Now, what no slip condition is saying? No slip condition is saying the fluid layer which is in touch, the fluid layer which is in touch with this, the fluid layer which is in touch with this movable plate bottom surface, it will also move with the velocity of 10 meter per second. That means what it's trying to say, the relative motion between this liquid surface and between this movable plate will be zero. Similarly, look at here, 100% this bottom plate, 100% this bottom plate is fixed plate. So 100% its velocity is zero. Now what will happen? Look at here. This liquid layer which is in touch with this bottom plate will be having velocity is equal to zero. Why the velocity is zero? Why the velocity for this is zero? Because according to no slip condition, this bottom, this fluid layer will be stick to this bottom plate, so that the relative motion will be zero. So look at here. According to no slip condition, relative velocity of fluid layer with respect to solid surface is zero at a solid surface. Yes. Chalo. Next, viscosity of fluid. What is viscosity of fluid? Anyone in the class? What is the viscosity of fluid? Look at here. What is viscosity of fluid? बोलो रे बाबा. What is the viscosity of fluid? Viscosity of fluid क्या होता है? बोलो रे बाबा. What is viscosity of fluid? It is the when the liquid is in motion. The internal resistance offered by one fluid layer or one liquid layer to the adjacent layer of liquid is known as viscosity. Here I am talking about liquid basically. If I am talking about liquid, what is the viscosity of liquid? When the liquid is in motion, the internal resistance offered by one layer of liquid to adjacent layer of liquid is known as what? Viscosity. Is it clear to everyone? बोलो यहां तक आपको clear हो गया? Are you clear till here? बोलो रे बाबा, are you clear till here? Now you remember I have told clearly what is the reason for the viscosity. First thing, there is some relative motion between the fluid layers. Second thing, there is cohesion between the liquid layers. Whenever we are having relative motion, whenever we are having cohesion between the liquid particles basically, I will be having the viscosity for liquid. Now look at here, this I have told you, for ideal fluid cohesion is zero. For ideal fluid, if cohesion is zero, what is the meaning of that? अगर ideal fluid के लिए cohesion zero है तो बेटा उसका मतलब क्या है? If for ideal fluid cohesion is zero, what is the meaning of that? The viscosity will be zero. Because why the viscosity is coming in the picture? Viscosity is coming in the picture because of what? Cohesion between the fluid particles, liquid particles basically, liquid particles. Okay. Now I have given you one beautiful conclusion. Do you remember? We have derived for a fluid flow deformation rate. For a fluid flow, what happens? Deformation rate. What is the meaning of deformation rate? d theta by dt. A deformation rate is also known as what? Shear strain rate. So for a fluid flow, deformation rate in bracket shear strain rate is always equal to what? Velocity gradient. Is always equal to what? Velocity gradient. What is the meaning of this mathematically? Look at here. look at here, mathematically, can I write deformation rate? What is deformation rate? d theta by dt is equal to what? Velocity gradient. What is the formula velocity gradient? du by dy. So this is the formula which we have derived. I'm not going to the derivation, but you should remember, whenever we are having a fluid flow, deformation rate will be equal to what? Velocity gradient. I hope you are clear till here. Next, analysis for linear velocity profile. Are you able to recollect this? Are you able to recollect this? What we discussed here? If I am having linear velocity profile, now I will be telling you what is the meaning of linear velocity profile. I hope you are able to recollect. Let me write it for you people. चलो वाइट से लिखने की कोशिश करता हूं. Let me say this is the fixed plate. Let me say this is the fixed plate. Let me say this is the movable plate. Okay. And let me say I'm having some liquid layers in between. Fine. Now look at here. Look at here, my friends. Let us suppose this is one cross section, and whatever the fluid particles are here, I am taking care of those fluid particles. I am discussing those fluid particles. So look at here. I am having one fluid particle here. Let me say I am having another fluid particle here. Let me say I am having another fluid particle here. Let me say I am having another fluid particle here. One fluid particle is there. I am taking out all these 5 fluid particles. मान लो मैंने 5 fluid particle आपके बाहर निकाल दिए. This is one fluid particle. Look at here. Look at here. These are those 5 fluid particles. Now let us suppose this plate is moving with the velocity capital V. So 100% what will happen? This fluid particle which is in touch with the top plate, it will also move with the velocity capital V. This fluid particle will not move at all because it is in touch with the bottom layer. देखो ध्यान से, like this. So 100% if I'm assuming the velocity is increasing from 0 to V linearly. If it is increasing linearly, I will be saying I am having the linear velocity profile. And for this linear velocity profile, what we discussed? किसी को याद आ रहा है? Are you able to recollect? For this linear velocity profile, what we discussed? We discussed everywhere the shear stress will be same. Tau is equal to what? Tau 1 is equal to tau 2 is equal to tau 3. Across section, everywhere the shear stress will be same, and it will be equal to what? Mu delta U divided by delta Y. What is delta U? Delta U is the relative velocity. Here, यहाँ देखो, ये velocity minus ये velocity. Here U is what? Here U is 0. Here U is how much? Here U is V. So basically this velocity minus this velocity divided by distance between them. This is basically delta Y. This is basically delta Y. I hope you are able to recollect. याद आया आपको? बोलो रे बाबा, type in chat box. Are you able to recollect? Fine. Now look at here. For linear velocity profile, uniform shear stress acts throughout the cross section in normal direction. Very good. Now for solving problems, number of times what will happen? They will not write anything. If they are not writing anything, you can easily assume that we are having the linear velocity profile and you can solve the problems. Now look at here. This is already I have given you. Now the Newton's law of viscosity. Do you remember what is Newton's law of viscosity? आपको याद है what is Newton's law of viscosity? Newton conducted number of experiments, and from experiments what he got? He observed shear stress is directly proportional to what? d theta by dt. So this is your Newton's law of viscosity. My friends. This is your Newton's law of viscosity. If I say Shear stress is directly proportional to shear strain rate. This is your Newton's law of viscosity. Now listen carefully. Now listen carefully. Listen carefully. We know that since d theta by dt is equal to du by dy. So what are we getting? If d theta by dt is equal to du by dy, what are we getting? What are we getting? Look at here, we'll be getting tau is directly proportional to what? Du by dy. Now, if I remove this directly proportional, I will be getting tau is equal to what? Mu du by dy. Mu du by dy. This is another format of Newton's law of viscosity. But remember, I don't know whether you are able to recollect or not. There is one very important condition. There is one very important condition. Are you able to recollect? Are you able to recollect that important condition? D theta by dt is equal to du by dy. For applying this equation, there is one condition. What is that? We are assuming u is changing with y direction only. U is changing with y direction only. So 100% whenever you are writing Newton's law of viscosity, tau is equal to mu du by dy, 100% there is some condition. What is that condition? We are assuming that u is depending on y only. U is varying with y only. It is not varying with any other direction. What is a small u? Small u is the x direction component of the velocity. X component of the velocity. Okay. Is it clear to everyone? Is it clear to everyone? Bolo re baba, bolo re baba, bolo re baba. Ah, yes, Nagasai. Yes, Chirag. Very good, very good. Wow. Excellent, Ananya. Very good. Are bolo re baba. Are you clear till here? यहाँ तक आपको सारा revision अच्छे से हो गया. Are you able to recollect all the things? Yes. U is the function of y only. Very good. Excellent. Shall we move forward? Bolo re baba. Shall we move forward? Yes. Next. According to Newton's law of viscosity, shear stress is directly proportional to the deformation rate in bracket shear strain rate, which we have seen. Now look at here. I will be discussing few cases where you have to tell me what will be the formulas, and then we will close the class. Now, Corti flow. Are you able to recollect what is the Corti flow? What is the simple Corti flow? Look at here. Let me say 1 minute. Let me say this is the fixed plate. Let me say this is the movable plate. Okay. Now, these are the fluid layers. These are the liquid layers. Of course, there will be a liquid layer which will be in touch with this top plate. There will be a liquid layer which will be in touch with this bottom plate. Now listen carefully. I'm assuming few things. Please observe. U is changing in y direction only. This is one thing. Okay, and I'm assuming velocity is varying linearly. Another thing, I'm assuming velocity is varying linearly. Now listen carefully. If velocity is varying linearly, what is the meaning of that? Let me tell you what is the meaning of that. Please observe carefully. Let me say these are the fluid particles I am having. These are the 5 fluid particles I am having. So velocity will be varying linearly. So this is the velocity profile I am trying to represent. This is the velocity profile I am trying to represent. Fine. Velocity is varying linearly. Now I am asking you one question. Listen carefully. Let us suppose this fluid is having viscosity mu. Let me say this distance is capital Y. Let us suppose this distance is capital Y. Now my question is very simple. What will be the formula of shear stress? If this plate is moving with the velocity capital V. If this plate is moving with the velocity capital V, anyone in the class? Bolo re baba. Yes. Bolo re baba. What will be the formula of shear stress? Anyone in the class? What will be the formula of shear stress? Are look at here. here what will be the U for this fluid layer? What will be the U for this fluid layer? Capital V. What will be the U for this fluid particle? U is 0. So what is the formula of shear stress? What is the formula of shear stress? What is the formula of shear stress? Shear stress is equal to what? Shear stress is equal to mu delta small u divided by delta y. Now tau is equal to what? Mu delta small u will be how much? Capital V minus 0. Delta y means capital Y. So shear stress will be equal to what? Mu capital V divided by capital Y. This is the formula of shear stress. Now let us suppose, I'm asking you one more question. Let me say the shear area, the area of the plate which is in touch with the liquid is AS. Then what will be the formula of shear force? What will be the formula of shear force? 100% shear force will be equal to what? Shear stress into shear area. So shear force will be equal to mu capital V divided by capital Y into AS. This is the shear force acting on the top plate. I am talking about top plate. I am talking about what? Top plate. Fine. I hope everyone is clear till here. Now listen carefully. Excellent, excellent. Now block sliding downward on inclined surface due to self weight. अब यहां पे बहुत इंपॉर्टेंट केस है बेटा. This already you know. I'm just doing it for you people. Let me say this is inclined surface. Let me say this is some inclined surface having angle of inclination theta. Let me say this is some block. Which is sliding downward because of self weight. Okay, let me say it is sliding downward with the velocity capital V. So you know na what will happen? What will be the force balance here? What in this, look at here, weight will be acting vertically downward, and look at here, this angle will be theta. So this will be how much? This will be how much? W sin theta. And 100% what is happening here? Look at here. In between, this I have discussed now, you remember? In between I am having some fluid. Let me say this fluid is having viscosity mu. And let me say this is capital Y. This distance is capital Y. Then can you tell me what will be the terminal velocity? What will be the formula of terminal velocity? In this case, what will be the formula of terminal velocity? Anyone in the class? We have derived. What is terminal velocity? The constant velocity with which block will be moving downward, with which block will be sliding downward. How are you going to solve such problems? I have told you. What will happen here? The shear force which is acting in this direction. Look at here. If you want to see what will be the direction of shear force, the direction of shear force will be this. This will be the direction of shear force. This will be the direction of shear force. So shear force will be equal to what? W sin theta. Shear force will be equal to what? It will be equal to W sin theta. So from here what I'm going to get? Anyone in the class? What will be the value of V? V will be equal to what? W sin theta into what? Capital Y divided by what? Mu AS. This is the thing which we have discussed. If you remember, in exam they will be asking you what is the terminal velocity. In exam they will be asking you what is the value of terminal velocity. Do you remember? We have derived like this. V is equal to W sin theta into Y divided by mu AS. आपको याद है ऐसा हम लोगों ने derive किया था? Do you remember this? Yes. Very good, my friends. I hope everyone is clear till here. यहां तक सबको clear हो गया बेटा? Look at here. If theta is zero, you remember we have discussed this part also. If theta is 0, sin theta will be 0. Sin theta is 0 means what? Terminal velocity will be 0. This is what we have discussed. That means if I am having a horizontal plane surface where theta is 0, the block will not move because of its own weight. but at the same time theta 0 means horizontal. Theta 0 means I'm talking about horizontal surface. And do you remember, if theta is equal to 90 degree, if theta is equal to 90 degree, that means I'm having the vertical surface. That means what? I'm having the vertical surface. And if theta is equal to 90 degree, what will happen? Sin theta will be 1 na. If sin 90 degree is 1, sin theta will be 1. Then what will be the formula? V will be equal to what? W into capital Y divided by what? Mu as. This will be the formula if theta is 90 degree. A special case, theta is 90 degree, sin theta is 1, we are getting V is equal to WY divided by AS. Yes, excellent. Yes, Prasad, very good beta. So are you clear till here? Excellent. Now I am going to the next case. Thin plate moving in horizontal gap. Listen carefully. Very important thing, my friends. Let us suppose I am having a gap like this. Let us suppose I am having a gap like this. मान लीजिए मेरे पास कुछ एक ऐसा gap है. Let us suppose I am having a gap like this. Now listen carefully. Let us suppose I am having a plate like this. Let us suppose I am having a plate like this. Please observe. Let us suppose I am having a plate like this. Let me say this plate is moving with the velocity v. Now listen carefully. Let me say here I am having some fluid. Let me say here I am having some fluid. Let me say here I am having some another fluid. Fine. Now look at here. Let me say this is YT. Let me say this is YB. Let me say this fluid is having viscosity mu A or mu T. Let me say this fluid is having viscosity mu V. Now first of all, can you tell me, if I want to pull this plate with the velocity capital V, how much force I need to apply? So can I say F will be equal to what? The shear force which is applied by the top liquid, mu T delta U. What will be delta U? V, here the velocity is V, here the velocity is 0. So V minus 0, V divided by the distance YT plus shear force applied by the bottom fluid, mu V capital V divided by how much? YB into area. Correct na? Into area. I hope you are able to recollect. ये सबको याद हो गया? Are you able to recollect this? Yes, excellent Prasad, very good Vakhar, very good beta, very good. Are you clear till here? Now after that I have discussed two more things. Condition for equal shear force. On both surfaces, on both sides. You remember what was the formula we derived? We derived mu T by mu V is equal to what? YT divided by how much? YB. This was the formula we have derived. And if you remember, we have derived one more thing. For condition for what? Beta? Minimum pulling force. Anyone remember what is the condition for minimum pulling force? Minimum pulling force? Mu T. Let me write in this way. What is the condition for minimum pulling force? देखो यहां लिख रहा हूं, ध्यान से देखना. YT by YB must be equal to what? Root over mu T by mu V. अरे चाहे तो इसको ऐसा भी लिख सकते हो ना, yt by yb. अरे बाबा same thing, if you want you can write like this also. Yt by yb is equal to what? Mu t by mu v. Are you clear till here? So these are the conditions which we are getting. These are the conditions which we are getting. I have derived also. Do you remember I have derived also? Is it clear to everyone? Yes, yes. Is it clear to everyone? Yes, 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 yes. यहां तक clear है सबको? Are you clear till here? Are you clear till here? बोलो रे बाबा, type in chat box. Are you clear till here? Are you clear till here? Then we have discussed solid cylinder rotating in hollow cylindrical cavity. Very important. Solid cylinder. Let us suppose I am having some solid cylinder which is rotating inside hollow cylindrical cavity. What will happen? Look at here. Look at here. So let me say this is the solid cylinder. This is the solid cylinder. Let me say having diameter d, and let me say this is the cavity. This is the cavity having diameter capital D. Okay. Now look at here, my friends. Let us suppose I am having some liquid filled in between. In this clearance, let us suppose some liquid is filled. Let me say this clearance is capital Y. This clearance is capital Y. So are you able to recollect this? Are you able to recollect this? Are you able to recollect this? What will be this capital Y? This capital Y will be what? Capital D minus small d by 2. Capital D minus small d by 2. I hope you are able to recollect. Now let us suppose this cylinder is rotating with omega angular velocity. Then what will be the linear velocity? V. V will be r omega. R is how much? D by 2 omega. D by 2 omega. Now here I have derived a number of things for you people. Here I have derived number of things for you people. Are you able to recollect? What was the formula of shear force here? What was the formula of shear force here? Pi mu omega d square. Pi mu omega. What is shear force? Shear force acting on this cylinder, inner solid cylinder. Pi mu omega d square divided by d square L. L is how much? This is your L beta. This is your L. So pi mu omega d square L divided by 2 capital Y. And you remember we have derived torque formula also. Pi mu omega d cube L divided by how much? 4y. And then we have derived the formula of power also. Bolo re baba, what was the formula of power? Power required to rotate this cylinder. Pi mu omega square d cube L divided by 4y. Each and everything we have discussed in a crystal clear manner. हर चीज हम लोगों ने पूरे अच्छे से डिस्कस करी है. Yes, 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 excellent, excellent. So my friends, we'll stop here. This we will discuss tomorrow. We will stop here. Now listen carefully. If you want to join Unacademy Plus, look at here. On Unacademy Plus, I am starting 3 batches. One batch is for third semester students. One batch is for third semester student. Beginners batch. There I am starting fluid mechanics. Another batch I am starting for 5th semester students in the month of August. There I am starting heat transfer. Another batch I am starting for final year students or passed out students. There I am starting separately heat transfer. So those who are interested, they can join using your own code. What is the code? Arey bolo re baba, what is the code? Code is Negi 10. Negi 10. Using this code, you can join Unacademy Plus, my friends. Using this code, you can join Unacademy Plus. Remember, Negi 10 is not just the referral code, it's an emotion. It's an emotion which is connecting me to you, which is connecting my classes to your learning, which is connecting Jam classes to Jam learning. So if you are interested for Unacademy Plus subscription, use Negi 10 and come on the Unacademy Plus platform. What are the benefits? What are the benefits you will be getting? Look at here. There are number of educators who are there on Unacademy Plus and they are teaching live classes. So you will be getting the live classes, and the moment you are using Negi 10, you will be able to access the classes of any educator, whatever you want, whatever you want. So I hope everyone is clear with this. Chalo, then thank you so much. We will meet tomorrow, and look at here. Tomorrow, what is the schedule? 4:30 p.m. I will be discussing what are the various opportunities through engineering sciences paper. Basically, I will discuss about engineering sciences paper. Okay, chalo, thank you so much. Bye, take care.